Now I want to talk to you about something called trigonometric identities. Actually, I only want to talk to you about one of them, and that's this one. There are in fact many trigonometric identities. Don't worry, we're not doing all of that in one go. Most of that will wait until a much more advanced course. But let's start with this one, and notice the way it's written. When we write cos² theta, we mean cos theta squared. And when we write sin² theta, we mean sin theta squared. That's a convention that means we don't have to worry about the parentheses. It makes things just easier to write. Now have a think about this unit circle. The x-coordinate is just the cosine of this angle, cos theta. And the y-coordinate is just the sine of this angle, sin theta. But then Pythagoras' theorem tells me that if I square this side and square that side and add them together, I'm going to get the square of the hypotenuse. But the hypotenuse here is just the radius of my unit circle, which is 1. So that means for the unit circle, for any point on the circle, x² plus y² must be 1. And so since x is cos theta and y is sin theta, that means for any angle theta, cos² theta plus sin² theta must equal 1. Well, you say, how does that help me? Let me give you an example. Find all possible exact values of sin theta when cos theta is a half. Well, if cos theta is a half, I can plug it into this relationship here, and the reason I'm doing that is because it relates for me cos and sine. I've got cos and I want to find sine. So put it in, a half squared is a quarter. Well, that means sin² is 1 minus a quarter, which is 3/4. And if sin² is 3/4, then sin theta must be plus or minus, remember there's always two solutions, plus or minus of the square root of 3 over the square root of 4, which is root 3 on 2. Well, you might say, I already knew that, because if cos theta is a half, I know the angle here must be 60 degrees, and therefore the only other option would be minus 60. Well, okay, but what if I give you an angle or a value that doesn't match that special triangle? So let's have a look here. What if I want to find cos theta if sin theta is 3/4 and theta is in the second quadrant? Now sin theta being 3/4 doesn't match one of our fancy triangles. But I can still find it if I remember that I know a way to relate cos theta and sin theta. And that is with our new trigonometric identity. So substitute here the thing I know. Sin theta is 3/4. Square it, square top and bottom, 9 over 16. That means cos² must be 1 minus this, which is 7 on 16. So cos theta must be plus or minus of root 7 on 4, 4 being the square root of 16. But I also know that my angle is in the second quadrant. Now in the second quadrant, I'm looking for cos. In the second quadrant, cos as the x is negative. So if cos is negative here, then I know that cos theta must be negative root 7 on 4.